Okay, there we go. I have 4 o'clock now, so we will go ahead and get started. Um, Today's topic is dictionaries. Finally, we've been hinting about these for a while. It's another data structure that's fundamental to Python. And not only that, it's fundamental to the way the internet works today. And we're going to be talking about that in the latter part of the lecture today. Administrative notes. Project 1 is available. It did not come out on Friday like it was supposed to, but it came out over the weekend. I think actually Sunday is when it became available. For our class, it is due Monday the 12th, 2 weeks from today. For the major sections, they have to do it Friday the 9th, but don't worry about that. For our sections, again, we're talking Monday the 12th. So you have 2 full weeks from today. It's actually not as hard a project as it looks. We're talking maybe 150-ish lines of code. Now, that does not include comments. Comments there should be a lot of, but actual Python code, my guess is somewhere between 100 and 200, depending on how you want to implement things. You know, ballpark 150-ish is about all it's going to take. Lots of comments, again, not included. We are going to walk through it a couple of times in the next couple of weeks. We're going to spend some time on it on Wednesday. I didn't want to spend tonight's class on it, this afternoon's class on it, because we do need to cover dictionaries. But take a look, get started, and we'll definitely put some time in on Project 1 on Wednesday. This is the last time we'll have the same project as the major sections. Project 2 and 3, especially 3, we go our own way. To try to get topics that are much more relevant to the kinds of things that you're majoring in, the kinds of things that you're interested in, and the kinds of things that you could use in your academic career. But for this one, we do the same as the majors, just it's due a little bit later. A reminder, homework 5 is due tonight. I have granted a few extensions to students. If you absolutely have to have an extension because of extenuating circumstances, let me know. I will, take into account that you've had other circumstances. It's a crazy world these days. But things are piling up. So I would remind you not to push off homework too late, because you do have the lab due on Wednesday, and Project 1 is due out, and you don't want to fall behind. Lab 8 tomorrow in class is on 2D lists, so that should not cause you any problem. Be back on the regular schedule for Lab 8. And a reminder, if you have not been contacting the TAs for office hours, please do so. That's a very valuable resource. The TAs know the stuff, they know the material, they've been around it, they're sympathetic, they're empathetic, they can help you. But you've got to make the effort to go see them. In addition, there's lots of academic tutoring available. There's messages out on Blackboard about the various resources I think you got available to you this semester for tutoring if you need it. So please avail yourself of the help that's out there. And of course, I'm here. I'm around. If you have questions or whatever, I'm happy to help as far as I can fit it into the schedule. So it's going to get crazy. Please work hard. You can do it. The grades of this class are really good right now. I'm pleased. I'd like to see that continue. Well, all that stuff is out there. Now, with that, let's get on to today's topic. Dictionary. A dictionary, as we said, is a fundamental structure in Python. Why it's called the dictionary is because it's analogous to the old paper copy of a dictionary, a thing you look up, Merriam-Webster, the Oxford English Dictionary, Webster's, et cetera, et cetera. It's a book where you have keys and values. A key is a thing you look up, a word or a phrase, right? What is the definition of rambunctious? Well, I go through the pages and I look for rambunctious, and I find a dictionary that says, I find definition that says this is what the word rambunctious means. Okay, or in this case, I literally decided to be recursive. Recursion is next week. That's a clue. and say, what's the definition of a dictionary? Well, the definition of a dictionary is a book that tells you the definitions and meanings of a bunch of words, and optionally tells you a bunch of other things. Well, the word you're looking up or phrase is called the key, and the meaning of it or other thing you're looking it up is called the value. So we're going to take that concept and specifically look at a list of keys and their meanings used by a computer programmer or system. It's a set of values that we associate with a key. Okay. So in Python, we have a dictionary, abbreviated DICT, dict for short. And here we use curly braces, right? We use parentheses for function calls and other things. We use square brackets for lists. We use curly braces, mostly, for dictionaries. So a dictionary, if you see curly braces, you know that's a dictionary. There's going to be a set of keys, and each key is followed by a colon and then the value. And the key value pairs of the dictionary are separated by commas. So in the simplest case, we're going to go to PyCharm for just a minute. I'm going to skip all that stuff because we're going to get to that later on. Some of the coding is we're going to do tonight's kind of tricky. I wanted to get it ahead mostly if I could. Okay, so defining a dictionary. We do something like this. The dictionary D equals curly braces, key 1, pardon me, colon, value 1, key 2, colon, value 2, and so on. And this defines a dictionary. And so if I look and say, what's the current value of D? I see curly braces, which tells me that D is a dictionary, and these are the keys, and these are the values. Now, those keys are strings. Keys can be integers or floats too. So I can say new D is a dictionary 1, you win. 2, sorry, that should be the integer 2, not the string 2. Nice try. 3, bronze medal. Okay, and that's just another dictionary with integers rather than strings. Okay, so that's how we define a dictionary. We assign a set of keys and a set of values. Let's go back to the slide. So this is basically what I'm saying here. The dictionary is a set of keys, colon, value, comma, key, colon, value, comma, and so on, however many you've got. That is how you define a dictionary. So, as an example, I have, over the course of the last few years, well, maybe more than a few, had a number of dogs. And I want to identify each dog with the type that it is. So I'm going to define this dictionary, and because of the funky quotes, I'm just going to type it in. My dictionary is going to be the dogs I have. It's a curly brackets. Now, my current dog, who is snoring behind me on his mattress, is named Doug. My daughter loved the movie Up, and if you recall the movie Up, the Pixar movie, the dog Doug was kind of the pal, the assistant, the one with the collar who spoke and said, I have just met you and I love you. So that's why I have a dog named Doug. Well, Doug is a mixed breed. He is mostly Beagle, which is spelled L-E, but he's also got a little bulldog in him. So therefore, we're going to define for the value Doug, his type, his breed, he is a mix of Beagle Bulldog. So I have a value that is a list. Doug's key, the dog named Doug, is the string Doug, that's his name, and his value, his type, is the list of Beagle and Bulldog. Now, my daughter's dog is named Lizzie, and Lizzie is an Australian cattle dog. Okay. So Lizzie has just the value string Australian cattle dog. Now, prior to having Doug, we had a dog whose name was Remy. I think it was spelled with a Y. All of these are shelter dogs, by the way, so they come with interesting names. Remy was named by the people at the shelter. They thought he was the color of Remy Martin cognac. My wife loved the name. Hey, Remy is his name, was his name. Remy was a shepherd, okay? And way back in the day, I had a dog named Penny, and as you might think from the name, Penny was a Cocker Spaniel. So here's another example of a dictionary, and I'm going to real quick input it into a Python console to make sure I haven't made any errors that'll come back to haunt me later on. And in fact, I actually got that right. So my dictionary is called dogs. In this case, I'm representing the names of my dogs and my daughters and what have you. And Doug is a mixed breed, so he has the value of the list Beagle and Bulldog. Lizzie is an Australian cattle dog. Remy was a shepherd. Penny was a Cocker Spaniel. So this is just another case of defining a dictionary. What are the keys? The keys are all strings. The keys represent the name of the dogs. And the keys in this dictionary are Doug, Lizzie, Penny, Bonnie, and, oh, I skipped one. Bonnie was a beagle. Let me go back and put her in because that's an important point. Hang on. Nothing like deleting your whole dictionary at once. Bonnie was a beagle. There we go. Oh, and I'm missing my quote at the end of a string. So let's try this again. Make sure I get everything in my example that I was supposed to have. There we go. I think we got it now. Let's go back to the slides. Okay, so my keys are Doug, Lizzie, Penny, Bonnie, and Remy. The values are the strings or the lists. Since Doug is a mix, his value is a list, and that's important. Values can be lists, okay? Keys cannot. We'll get to that. Now, rules for keys and values. Keys must be unique. And for now, don't worry about this word immutable that comes up in gory detail on Wednesday. But for now, keys have to be unique, and they can be int, floats, strings, or booleans. Not lists or dictionaries. Okay? So a key cannot be a list and it cannot be a dictionary. For now, keys are ints, floats, strings, and booleans. Keys must be unique. This is, no pun intended, a key point of dictionaries. They can only appear once in a dictionary. And think about it going back to the paper dictionary again. Okay, if you've got the word sharp, the word sharp certainly can have more than one meaning, as we know. In music sense, a sharp indicates a variation on a note. In clothing, sharp represents somebody who's really dressing well. In intelligence, sharp represents somebody who's pretty smart. In knives, sharp means something that's got a pretty good edge that's going to cut stuff fairly quickly. So sharp has more than one meaning, but sharp does not appear in the dictionary more than once. Sharp just has values that might be a list that might be more than one thing. You can't find sharp on page 25 and then sharp on page 96. It would be horribly confusing. The word appears in the dictionary once, sharp. If it has a multi-value, it has multiple values, then it can have a list or it can have a dict, but it can't appear twice. So the rule in Python is the same. A key has to be unique. It cannot appear in a dictionary more than once. Okay. And again, for our sake, right now it's ints, floats, strings, and booleans. More information on Wednesday. Okay. They cannot be lists or other dictionaries. Values can be anything. Literally anything that we have covered in Python so far can be a value. A value could be an integer. A value could be a string. And in the examples I put in PyCharm so far, values are mostly strings. A value could be a float. A value could be a bool. But importantly, a value can be a list. And in the dog's example, I gave you a case where with Doug, his value is a list because he's a mixed breed. He's a mutt. Okay. He's a lovable guy, except for now that he just barked. But he's he's a mixed breed, so his value, he has more than one value. His value is a list. List cannot be a key, but list can certainly be values. And dictionaries can also be values. You can have nested dictionaries. We're not going to get into that today, I don't think. But yes, you can legitimately in Python have values in dictionaries that are themselves dictionaries. You can nest these things. Just like on Wednesday of last week, we talked about 2D lists, lists of lists, lists whose elements are themselves lists. The same principle applies with dictionaries. You can have values that are themselves dictionaries. You can nest these. You can have 2D dictionaries or 3D dictionaries or as hideously complex as you want. Okay. It's all right as long as it's a value, not if it's a key. Furthermore, values do not have to be unique. Okay, I can repeat them. Just going back to my dog's example, note that Doug is a beagle, or is part beagle. Bonnie was all beagle. Okay, the value beagle appeared. And my family, when I was growing up, tend to love beagles. I think over my lifetime, I've probably had about 6 or 7 different beagles. Beagle could appear in a value more than one time. There's a beagle. There's a beagle. As values, that's okay. After the colon, that's fine. You can repeat it. Keys, the things before the colon, have to be unique. Values, the things after the colon, do not have to be unique. They can be repeated. So, difference between keys and values. Keys are what we're going to look up in a dictionary. They must be unique, and they can only be ints, floats, strings, or booleans. Values can be anything. They do not have to be unique, and they can be ints, floats, strings, booleans. They can be lists. They can be dictionaries themselves. Values can be anything. There's no restrictions. All right, those are the rules. I showed you how to create a dictionary by putting values in it. You could also create an empty dictionary with just an empty curly brace. Okay. Another example is if you want to create a dictionary that lists all the governors currently of the states. Okay. Well, the governor of Maryland right now is Larry Hogan. So we create a dictionary that says for Maryland, the governor is Hogan. For Virginia, the governor is Ralph Northam. So you will say for the key Virginia, the value is the governor Northam. The governor of Louisiana is John Bell Edwards. So we'll say Louisiana Edwards. Okay. So we could create a dictionary this way. This is how I've done it in PyCharm, and you could do it the same way here. If you want to create an empty dictionary, just use empty curly braces, just like with a list and square brackets. Couple of other points. I'm sort of rambling here because I'm going to throw you everything before we get into the actual coding part, but we need to make some points. A list is ordered. In Python, a list is ordered and order counts. When I talk about a list, I say index sub 0, sub 1, sub 2. Or if I want to start counting at the end of the list, it's sub -1, sub -2, sub -3, and backward. Okay. So if I have a list of students, the students in the class, then what's important is where in the list they are. Student sub 0 is a specific student. Student sub 1 is a specific student. Student sub -1 is another student. Dictionaries have no order. It may seem that when I create this dictionary, well, the first entry is Maryland, which makes sense. That's where we live and where we go to college and who signs my paycheck and all this other stuff, right? Maryland comes first, Virginia comes second, Louisiana comes third. However, internally to Python, Python can store this any way it wants. That's the rule. Python doesn't have to keep track of what comes first, what comes second, what comes third. So there is no notion of governors sub 0. Okay? There's no notion of this. This thing doesn't exist. You don't say, you know, the first entry in governors. We don't know what that is. You may seem to think, you know, that I'm going to look at this and I'm going to say, well, the first entry is Maryland, so the first value is obviously Hogan. No. Dictionaries are unordered. The only way to access an element in a dictionary is by referencing its key. You cannot reference its location. And that's one of the major differences between a list and a dictionary. In fact, that's actually the core difference between a list and a dictionary. A list, if this is the proper slide, no, it's not. Okay. A list states a relationship between a value and an index, a location. If I want to look up this particular student, I look up student 0. If I want to look up this particular student, I look up students of -1. That's where I get the student record. In a dictionary, it is a relationship between a key and a value. If I want to find a value, I have to specifically state the key. I cannot say governor sub 0 or the first entry in governors. I can't find my buddy Doug here by saying the first entry in dogs. I have to say specifically Doug. Okay, so the only way you access an element of a dictionary is by key. And here is where it gets confusing because we're reusing square brackets. We're overloading. I know square brackets mean lists, but if we have a dictionary, square brackets are which key I want to use. So over here, again, let's make sure I have the right value. This is my dictionary. This is my dictionary called dogs. Now, what if I want to find out what type of dog Doug is? I say dogs, square bracket, the key is Doug. And Python returns Doug has the value, the list, Beagle, Bulldog. So Doug is a Beagle and Bulldog mix. Okay. If I said in parentheses, dogs, Doug, I would get an error because we don't use parentheses, we use square brackets. So yes, square brackets in context mean lists, but when we know we are talking about a dictionary, square brackets define the key. So dogs, square bracket, Remy. Remy was a shepherd. So square brackets say this is the key, and this that I get back is the value associated with this dictionary entry. Dictionary key returns the value. Okay. Now, trying to make sure I follow the slide order. Okay. So as I said, dictionary dogs of Doug gets you the list Beagle Bulldog because he's a mix. Dogs of Remy gets you the string Shepherd. What if I give a key that's not there? Okay. Many, many, many years ago, I had a dog named Pepper. Pepper was also a bulldog. He was an English bulldog, but he's not in my dictionary because this is only my recent dogs. But I'm going to ask, what type of dog is Pepper? Well, I get a key error. Key error means that this key does not exist. It has no value. Okay. So my program crashes, my program dies because I forgot I didn't create a value for Pepper. Pepper was a bulldog. I didn't put that in. Oh, this is not good. So that answers the point on the slide that says what happens if the key is not present. If I say dogs Pepper and Pepper doesn't exist, the program crashes. Well, I want to be able to deal with it. I want to have something that's resilient to errors. Okay. And that is with a method for dictionaries called get. Okay. And dogs.get, dictionary name dot get key value Pepper. Remember our friend none from functions. Well, here it comes again. If this key using get, if this key doesn't exist, then my program doesn't crash. I just get the special value none returned. So you can just make sure that none is not returned when you want it. Let me try that in English. You make sure that you don't return none before you go on with your code. And the way you do that is to use the get method and then put it in an if statement. So something like if dogs.get of Pepper is not equal to none, and remember it's the special value none, then I print didn't crash. Sorry. And in this case, Pepper, dogs.get of Pepper is equal to none because Pepper doesn't exist in the dictionary. I didn't do anything, but the bottom line in this is when I just said print dogs of Pepper and Pepper didn't exist, my program crashed. The get method is a way of being more resilient. The get method is a way of making sure your program doesn't crash just because you used a key that didn't exist. So what get does is it allows you to have your program keep working even if the specific key doesn't exist. Now, the nice thing about get is you can make it return something other than none if you want, and that is you give it a second argument in the call. So print dogs.get of the key Pepper. Nope, sorry. This really should have been parentheses. There we go. And it returns the value none. So dogs.get of Pepper returns none. If I want to make it return something else, I can say print dogs.get of. I had another dog back in the day whose name was Baron. Barrett's not in my dictionary yet either, but the dog, I'm going to return this string. So what this does, and what I'm illustrating here is, by default, if the key is not there, Pepper's not in the dictionary. If the key is not there, get returns none. If I don't want get to return none, I can define another one. Here I said, if Barrett is not there, if the dog's not there, return this string. And indeed, I returned the string. It did not return none, it returned the string. I can make it return an integer that often we use -1 for. -1 means you got an error. So in this case, I'm going to look for Cleo. Cleo was also a beagle back in the old days. Cleo's not in the dictionary, return -1. All of that mess is to say that I had a dictionary. I can check to see if a key's there before I crash, and I can return whatever I want. I can allow the default return. If you use get and the key's not in the dictionary, the default is get returns none, a special value of none type. If you want to make it return something other than none, you can return the string. The dog's not in the dictionary, the key's not found. You can make it return an integer -1. You can make it return whatever you want. Okay. So if you're going to be fetching things from the dictionary and you're not sure whether they're there or not, it's probably best to write defensive code, resilient code, using get rather than just directly accessing the key. Okay. Now, what if I want to add those dogs to the dictionary? They're not there. Okay. The way you add something to a dictionary is you use an assignment statement. You don't append, you don't insert. The reason is there's no notion of order, as we said. Append in a list, remember, append adds the value at the end of the list. There's no notion of end of a dictionary. Insert puts the value in a specific slot in the list, so you now know that this is student number 15 and you keep your alphabetical order correct. There's no notion of order in a dictionary. It doesn't make any sense to insert dog number 15. Okay? If you use an assignment and a key already exists, this statement overrides that. It doesn't add a new element. Let me explain what I mean by that. So here is our dictionary dogs. And I see that Cleo doesn't exist. So I'm going to be resilient in my coding, and I'm going to say if dogs.get Cleo equals none, that means Cleo doesn't exist, then I'm just going to say dogs.Cleo gets assigned beagle. Hang on, I got that wrong. Square brackets, not dot. What am I thinking? Dot, sorry. There we go. So what this code does is it says, hey, is Cleo already a key in the dictionary? If Cleo's a key in the dictionary, I don't do anything. If Cleo's not, I just assign it. Okay. Now let's look at dogs. Hey, lo and behold, I've added Cleo to the dictionary. In the example I give in the slides, I use Cinder. Cinder's a Doberman, same idea. Just do an assignment statement. And again, to protect myself, I can just put this in an if statement to make sure that it's not there. Because here's why. I've already added Cleo as a beagle. We verified Cleo's a beagle. Now, I don't bother to check. I don't think Cleo's there. So I'm going to just say dogs of Cleo is, I don't know. Let's say she was a dachshund. She wasn't, but that's okay. Okay, so let's come down here and execute that statement. And now when I look at dogs, I see that lo and behold, I changed Cleo from a dachshund, from a beagle to a dachshund. And I probably didn't want to do that. When you have an assignment statement with a key that's not there, and this if, just check to see if the key's not there. So the key's not there, and you have an assignment statement, this just adds a new entry to the dictionary. If you already have the key, if the key already exists, and you have this statement, then it overwrites the existing value. It changes the value from what it was to here. It doesn't add a new entry. Remember, it can't add another key of Cleo because keys have to be unique. Cleo's already there. It can't add another one. That's not allowed. So it either has to add dachshund to what's already there or change it, and Python says we'll change it. So adding a key value pair to a dictionary is simply a case of an assignment statement, but if the key does not exist yet, the assignment statement adds a new one. If the key does exist, the assignment statement overwrites what was there before. That's what I've got on that slide. Okay, so that's what we say here. Just use an assignment statement, dictionary name, square brackets, key, value. Again, there's no append or insert or anything like that. It's just this assignment, and it goes wherever it goes in the dictionary. If that key already exists, you just overwrite the existing value. Okay, it changes the value of the existing key to the new one. If you remove an element from the dictionary, it's just delete, D-E-L, del. Okay, but if that key doesn't exist, you're going to get an error again, and your program may crash. Okay, so here we have our dogs. Now, I want to get rid of, Cleo was back in the day, she was a wonderful dog, but we're going to get her out of the dictionary because that's ancient history. The del command, or the del method, just removes that entry. Whatever matches this key is gone. But if I use something that's not there, del dogs of lady, lady doesn't exist, and here I am with my program crashing with the nasty key error again. Key error means it's not there. So again, what I would do is I would code defensively. If I'm not sure that dog is in the dictionary before I delete it, I'm going to be careful. I'm going to say if dogs.get of lady is not equal to none, then I'm going to delete dogs of lady. This has the effect that if it is equal to none, if lady is not in the dictionary, then I don't execute this delete and my program doesn't crash. So that's one way of being more robust, more resilient, of not crashing when you're executing code. Okay. So you can also, in addition to deleting, you can pop. Pop is analogous to get in that if there's an error, if the dog is not there, if the key is not in the dictionary, rather than crashing, it just returns a default value, which you have to specify. You can say if lady's not there, return none or return -1. So going back to PyCharm, I can simply say dogs.pop of lady. If lady is not there, return -1. And the result of this is -1. So I wind up with something like this. If dogs.pop of lady and return -1 is equal to -1, print that dog wasn't present. And therefore, my program runs, it doesn't error out, it doesn't crash, it gives me some response. So what we can see from this is we can remove an item from a dictionary with either the delete statement or the pop statement. If we use the delete statement, we need to do something else to guard against the program crashing because the key's not there. If we use the pop statement, we can be more defensive and we could put in something to do if there's an error so our program doesn't crash. There's actually there's another thing we don't really talk about except just to let you know it exists, called pop item. Now, pop item used to be interesting when I first started teaching this course. This is my 4th semester. So when I first started teaching this course, we used Python 2. And in Python 2, if you used pop item, it deleted a random element from the dictionary. I have no idea who thought that was useful code. I really don't. But pop item would pick an element in the dictionary at random and delete it. Really bizarre. It existed. It was fun. I mean, from a data science standpoint, you could do some probability measures, but, you know, why? It does exist. We're not going to use it. Now, as of Python 3.7 and now 8 and 9, pop item just removes the most recent item you inserted into the dictionary. Again, I don't know why you would normally care about that unless you're doing something like me where I'm inserting and removing and inserting and removing to show you how to insert and remove. In general, you're not necessarily going to care about putting an item in the dictionary and then immediately deleting it. But you have a way to do that if you want. You have that method, and that's called pop item. You're not going to use pop item in any coding. I'm not going to put it on a test or anything like that, but that's what it is. It removes the most recent item, the last item you put in the dictionary. And it used to be more interesting because, as I said, it used to pick an item at random from the dictionary and throw it out. Okay, again, this is what I said earlier. I put this slide later in this presentation for some bizarre reason, what have you. Difference between dictionary and list. List, add value, an entry, and its location, an index. It binds the location, the order, to the value. A dictionary, there is no order. It binds the key and the value. So it comes down to a list is ordered, a dictionary is unordered. And that just might be a multiple choice question on exam 2 in a couple of weeks. When do you use a dictionary versus a list? If you have a list that you care about orders. I have a list of student IDs, I keep a numerical order. I have a list of students, I keep an alphabetical order by last name, whatever. Order is important, I use a list. If I have a set of unique keys that each map to a value, then I would use a dictionary. I wouldn't use a list to keep my dogs because, for example, if I say, you know, dog sub 0 is beagle bulldog, dog sub 1 is shepherd, dog sub 2, that doesn't connect to names. That doesn't tell me which dog. I have to separately remember that this first dog was Doug and this second dog is Lizzie and the third dog is Remy and what have you. So when I care about mapping name to type, name to breed, name to type, whatever, that's a dictionary. That's something that fits much better. If I care about order, like the students in alphabetical order, that's a list. So that's when we want a dictionary in Python versus a list. Now, I have some stuff in the slides. It's just another example of using a dictionary to keep a recipe in this. I kept the item, and then the key was the item, butter, flour, sugar, baking soda, and the value was how much of that I needed, because we used to give a homework assignment where you had to write a program that used dictionaries to manipulate items in your recipe. I'm going to skip over that because there's something that's more relevant to you, and this is what we're going to spend the next half hour or so on in the class. Okay. If you use the internet, the World Wide Web, for much of anything, and you have to transfer files back and forth, you hear the term JSON. JSON, like the name, or JSON, depending on how it's pronounced. JSON stands for JavaScript Object Notation. JSON is a standard, or really the standard way of exchanging information across the internet. When you load a file from one place to another, very often it's going to be a JSON file. Now, here's an example for you. Okay, I apologize for doing this, but yes, I am that geek, and I'm proud of it. This is my fairly new Apple Watch that I just got. This is my Fitbit that I've had for about 5 years. I'm switching over from the Fitbit to the Apple Watch just because the Fitbit is now passe and the Apple Watch is geekier and I can show off. Okay. Fitbit has my 5 years of workout history and everything else that the Fitbit band has recorded. There is no easy way to move that 5 years of history from my Fitbit record to my Apple Watch health app. There's just no easy way to do it. Neither Apple nor Fitbit is now owned by Google, I believe. Neither of them wants to make it easy for you. They want lock-in with their specific product. And so it's a real pain in the neck to transfer all of my Fitbit data into Apple so I don't lose it. Now, there are third-party products. There are apps I can buy that will do it for me, but that's kind of an insult. That offends my computer science street cred that I have to buy an app to move the data for me. So I want to do it myself. Luckily, it turns out that JSON is just a list of dictionaries, and we'll see that in a minute. There's one more thing I do have to hit. It comes up later. All right. So I went to Fitbit, into my account, and I said, download my entire history. Okay. And what I got from my history is a set of files that are all .json. So I have some of them stored in a directory on my Mac. And so just to show you, the directory is called JSON files. It's in my documents. It's users, Alfred Arsenal documents, JSON files. And we'll see by listing it, because remember, Mac is like Linux and just doing the list, I have all of these files .json, because that's what's standard for transferring data across the internet. That's what Fitbit provides you when you say, I want all of my records. These are just the steps. I didn't show you the heartbeat and the mileage and the number of floors and everything else. You just get these horrible number of files. Now, what they are, they'll turn out, I'll cat this first, but then I'll show you what it looks like in the editorial file because it's easier. So let's cat the file steps. And you have to spell it right, -2016 -07 -03. Hang on a second. What did they do? Oh, .json. Okay. That's what that one file looks like. Yeah, that's a pain in the neck. Let's look at what that file really looks like. Okay. This is the JSON, the JavaScript object notation file you get from Fitbit. Notice the square bracket right here. That says in Python, it's the beginning of a list. And if I go down to the end of the file, there's my closing square bracket. That square bracket matches the one at the beginning of the file. So this is a list. What are the elements of the list? Well, look at this open curly brace and this right curly brace. That is a dictionary. Curly brace, curly brace. T, colon. I don't want you to leave. Value, comma, key, colon, value, right curly brace, comma. Remember the list, the elements of a list are separated by comma. Here is another dictionary. Key, colon, value, key, colon, value. Now, you can see that the keys are repeated, but that's not using a key or reusing a key twice in the same dictionary. This is a dictionary. This is a different dictionary. This is a different dictionary, and so on. So a JSON file, a JavaScript object notation file, standard across the internet, is essentially in Python a list of dictionaries, which is cool because now that we know how to process lists and now that we know how to process dictionaries, we know how to do things. Now, in this case, what this means, what this does, and literally this is what Fitbit does if you use it, it records every minute the number of steps. This is the steps file. There's equivalent files for mileage, and there's equivalent files for number of floors, and there's equivalent files for heartbeat, and there's equivalent files for, if this applies to you, menstrual health, and there's equivalent files for sleep, and there's equivalent, yeah, Fitbit does a lot of crap. Yeah, it's not crap, but at any rate. Suppose that I want to find out how many steps I took. Now, remember last Wednesday I said you learn a term, EDA. EDA stands for exploratory data analysis. All that means is look at your data files and see what you got. Well, what I've got is in this 1 minute, I took 8 steps. In this next minute, I took 8 steps, or 28 steps. In this next minute, I took 0 steps. Goofing off. If I go all the way down here, I see that this file starts on July 3rd, 2016. I told you I've had it for about 5 years. And it ends on August 2nd, 2016 at 3:01 in the morning. And there were 0 steps, which is good because I had 0 steps there. It's quite interesting that on August 2nd of 2016 at 3 o'clock in the morning, I took 72 steps. The reason to that was I happened to be in California at the time, and so that was only midnight. I really wasn't walking around my neighborhood at 3 o'clock in the morning here in Maryland. I have my Fitbit set to Maryland time, Eastern time. So at any rate, if I want to find out how many steps I took in this 28-day period or 30-day period, it turns out to be fairly easy. And that's the code that I put in this file that I was doing earlier that I skipped over. Let's get back and see how it does. Now, it turns out when you have a file that's a list of dictionaries, it's kind of a pain in the neck to force fit yourself. I mean, you can use read, right? We can declare the file name and open it for reading and read the file and then process that ginormous string as a list of dictionaries. Python gives you some tools. We're not going to worry about it now. I just happened to use some existing Python tools, and I got a list of dictionaries, and that's what I cared about. I declared a path name that said, this is the directory all those files are in. There is, we'll get into this later this semester, don't worry about it now. There's a way to list all the files in any given directory. So I just said, give me all the files in this specific directory, and I put it in a for loop, and I said, these are all the file names. And then I checked, not all the files in that directory are JSON files, by the way. I got a couple of additional cache and other files in there. And I don't want to mess those up, so I'm just going to say, if this is a JSON file in the directory, I'm going to read it in. All of this stuff does, and I will post this, but don't worry about it if you don't get it now. We'll get to it later in the semester. All of this stuff does is it reads in the file, and now I have a list of dictionaries, which is what I wanted. Okay, so we'll go to, just to get some intermediate stuff. Let me just copy a little bit of code down here. I'm going to read in the full directory. I've been doing this so much over the last couple of days, making sure that this demo would actually work, that I know this directory by heart. I just have to spell it correctly. And I'm going to give the actual file name steps-2016-0703 or 0307.json. Now, real quick, I'm going to double check that I got that right. Steps-2016-0703. Okay. Okay, let's fix that. It's 0703. There we go. Now, let's open that file with open path for read as in file. The command to read this in and make it already be a list of dictionaries is just d equals json.load in file rather than read. Okay. And now, there we go. We can see, just to verify that what I have done with this command is this just reads in the file, and now I have a list of dictionaries, which is what I had in the JSON file. And I could show you how to do that with infile.read that we've already covered, but it gets to be kind of a pain in the neck parsing everything out. So for now, all this is it reads in a list of dictionaries. Now, I want to count the number of steps I took in that period from July 3rd to August 2nd. And so I'm just going to run a loop and take the value of the number of steps for each entry. So each dictionary has a key called value. Value means the number of steps. And it has, this is confusing, I apologize, this is Fitbit for you. It has the value associated with that key is the actual number of steps you took. Okay, that's this 0, that's this 72. So what I want to do is go through this entire file, go through each dictionary. From each dictionary, find this key and take this value associated with it and add them up. Now, as you can see, they're all strings. Okay, they're all strings. This is the string 72. This is a string of 0. So I'm going to have to cast it to 0. Okay, and all right, cast it to an integer. And so what I do is I start with steps equals 0, and then I go through D. D is a list, so it has a length. It has a number of entries in it. And I take that item and I cast it to an integer and add it up. So let me walk through this and show you exactly what's going on. So I initialize steps to 0 because I'm going to count all the steps I took. I got to start counting at 0. Now, I have a list D for I in range length of D. So for every element in the length, every element in D, my list, which is what got read in right here, that's a list for every element in it. I'm going to add the number of steps. Well, the number of steps is equal to D sub I, but that's the D sub I is an element of the list. What's an element of the list? It's a dictionary. D sub I is this stuff in the curly brackets. D sub I is a dictionary. It's an element of the list. It's a specific dictionary. So that's what D sub I gets me. Now, what do I want? I want this, which is associated with this key in the dictionary. The keys in the dictionary, here's a dictionary. The keys are the string date time and the string value. Those are the two keys. I want this key. So to get it from a dictionary, to get this from a dictionary, I say I want to use the key. The key is the string value. So D sub I is the list element. It is a dictionary. This says take this key and find the value associated with it. So this will return the string 0. It will return the string 72. It will return the string 0, and so on. Now, again, those are strings. I can't add strings together, so I need to cast it to an int. So all this says is find a dictionary. In the dictionary, find this key. Get the value that's associated with this key. That value is this string, is this string, is this string. Cast it to an integer, and now add it to steps. And when this is done, I will know that in the period covered by this file, I took 320,726 steps. I got 320,000 by adding up all of those individual items in all of those individual dictionaries. I added this 0 to this 0 to this 0. Let's find something. This is 0 to this 7 to this 18 to this 13, because Fitbit stores all of this again as a list of dictionaries in an individual file that covers about 30 days, and you can add them all up. Now, what I did in the code, which, as I said, I'm going to post to GitHub after the class, is remember that directory had all the files. That specific file I read in gave me the number of steps in that period. I wanted to get all the steps I had in the 5 years I had the Fitbit up through this file, December 9th, it went into the beginning of this year. It went into January. So how many steps did I take, according to my Fitbit, for the entire time I had the device from 2016 up through January of 2021, through December 2020, January 21. Well, all I did there was this that I took to calculate the number of steps in each file. I repeated this over and over. Now, this isn't going to give you the grand total. This is to show you that it runs, and I'm going to kill this. I'm going to quote all of this out so that I don't have my program error out on me because of the dogs cases. And now this should run. And you can see that each month I had a bunch of steps. 117,302, 342. That doesn't give me the grand total. If I want the grand total, that's fairly easy to do. I'll add a statement that says grand total steps equals 0. And then for each month, I will add grand total steps plus equals steps. Okay. And when the whole program is finished, and I'm all the way down here, I will print the grand total steps. And now, if I didn't make an error, I'm going to comment out this print statement so that I don't waste a lot of time when I run my code. And what did it do? Here we go. It took a long time to finish. It took a long time to internet that are in these JSON files. You as Python coders, as computer scientists, you as computer scientists are able to write your own code and use that and just do, all the calculations. I don't need to pay somebody for a third-party app because I know how to program with lists of dictionaries. And all I had to do other than that was remember to cast the string, the numbers which are strings, to integers, write some loops, add them all up. Okay? Because all this stuff is just lists of dictionaries, because this dictionary notion of a matching of key value, key value, key value, key value is very, very strong. Very, very powerful was the word I meant to use there in coding. Now, one last thing before we wrap up, since that actually finished 7 minutes ahead of time because I debugged the blasted code an hour before lecture rather than debugging it during lecture, which is probably something I should do more often, but we'll go there. We won't go there. How do you get a dictionary entry by its value? And the answer is not directly. You can only see if any key has that value. So let's go back to the dogs example. Okay, let's start with my dogs. And let's reload them just to make sure we haven't messed anything up. Cool. What if I want to find out if there's any dog who's a beagle? Okay, I know how to look at Doug. I know how to look at Bonnie. Can I find any dog who's a beagle? Well, it turns out not directly. What I have to do is check every key and see if any key has a value of beagle. So what I could do is say for key in dogs.keys, if dogs of key equals beagle, print key. Okay. It didn't show Doug because beagle is part of a list. I would have to modify the code a little bit. The point of this is simply this. If I gave you a dictionary definition, if I gave you a definition, say the definition for rambunctious. Doug has been rambunctious today. This is why this has come up. If I give you a definition for rambunctious and ask you to go through the dictionary in the Kuhn library in AOK and say, find the word that matches this definition, you're going to be there all day. Because you have to start at the beginning and you have to go through until you find some word that actually has that definition, if it is meaningful. Well, Python dictionaries are exactly the same. Fortunately, computers are really good at looking at all possible values for us in most cases. The only thing I can do, if you want to start with a value and find the key that matches it, if you want to start with the dog's breed and find the dog that is of that breed, you cannot directly access an entry in the dictionary by its value. The only thing you can do is you can look at every possible key and say, does this key have that value? If I wanted to go through all of my steps files from my Fitbit logs, right, and say, were there any 1 minute ever where I took 100 steps? You would have to go through every file, every dictionary entry, everything, and look for something that matched 100. You can't just go to the key. Okay, if you're looking with keys, you have to go to the key value. You have to go to the key entry. If you can't access a directory of a dictionary, you can't. Let's try this in English. You can't access a dictionary by value. All you can do is look at every key and see if a value matches what you want. Whereas with the key, you go directly into the dictionary and look at that specific entry. That's the point I'm trying to make. Key, I can look at the entry and find the value. Value, I cannot. The only thing I can do is look at every entry. And again, the analogy is the paper dictionary over in AOK. If I tell you to look up the definition of the word rambunctious, you can do that, right? You know how to find the R's and find rambunctious, and you're good. If I gave you the definition of rambunctious and asked you to find what word it is, you're in trouble because you have to look at every possible entry and hopefully find one that works. And probably going to take you hours and hours and hours. Fortunately, again, the computer can do that. We can tell the computer to go do this. There's a couple more things on dictionaries I do want to talk about, and we will cover those on Wednesday, but you should be able to, if you haven't finished the lab from last week, you should now be able to get that. You remember you have until Wednesday to do it. Okay. This week's lab that you have tomorrow is 2D lists, so that we've covered, which should be straightforward. Homework or the project that's out there, you should be able to get started. We will talk about the project on Wednesday, I promise. And then we have the lecture on mutability on Wednesday. And that's it. It is now 5:15. I'll hang around for a while. If anybody has any questions, I will stop recording. And other than that, I will see you on Wednesday. So does anybody have any questions?